Hello and welcome to Beginners Python and Machine Learning. My name is Tim Cummings. Tonight's session we're going to be focusing on absolute beginners, so people who've never used Python before. We're just going to give you a bit of an introduction of how to get in there and start playing around with it and try to demystify some of the terms that you come across. So this is a live stream session, so if you are watching it live, you can ask questions, and the questions are probably more important than the content, because then I know exactly what it is that you're missing out on at this stage. Well, we've got a couple of questions already. Will this video be accessible later? Yes, it will. So we stream it live, but you can watch it later. Yeah, so the same link should work. And so you can ask chat questions on YouTube chat, or you can even ask questions on Slack. So Learning to Code channel inside our session, which is Beginners Python, and there's instructions below to tell you how to get an invitation to our Slack channel. All right. So the way we're going to do it tonight is we're going to use Google Colab. So Google provides a free service that lets you run Python without even having to install it on your computer, and it's actually a very powerful service that they offer. So some people just live in Google Colab and don't ever get around to installing Python on their computer. Now I've created what's called a Jupyter notebook in Google Colab, and so that'll be our script for tonight's session, and I've given you a link below. So this is in Meetup, but the same link should also be there underneath this YouTube video. So if you click on that link, it'll take you to Google Colab. Now you might, if you want to make changes, you're going to need to have a Google account, like a Gmail account. But I think it might even work without that. I'm not sure. Anyway, I've created this from my account, and you see here it says changes will not be saved. That's because I'm now in a different account, and so of course you don't have permission to make changes to the original document, but you can click on here, copy to drive, and that will allow you to have a copy that's saved in your area in Google Colab, and you'll be able to make changes to that. So I'll do that. It opens up in a new tab, and I'll get rid of this error this message at the top about private outputs. That's just so you can't see the answers before you come to them. And you can see the release notes here on the right, and it shows you all the things that are installed in this Google Colab environment, that have been upgraded recently. Google have actually lifted their game quite a lot. They're now giving us much more recent versions of Python in Google Colab, but we can close that for now. So this is what a notebook looks like. First thing, I'm just going to click on connect up here. It doesn't matter if you don't do it, it'll just slow you down a bit later when it realizes you actually do want to connect, and it'll do it automatically for you. These notebooks are made up of cells, and a cell, like this bit I've written at the top, is with formatted text. That's called a text cell, and you can see it's got a rectangle around it. I've just clicked in the next one down, it's got a rectangle around it. So these are called text cells. And then the next one down here I've got is a code cell, and it looks slightly different. You can see it's got a bit of a shading on it. It's got a play button here, so you can play the code that's in the cell, and it does some color coding based on the what sort of code you've written into the code cell. And you can create new cells at any time. See, if I hover between this text cell and this code cell, I hover between it, it says, do I want to put in another code cell or another text cell? and you can do that yourself. You can put in text cells to say that if you want to put notes in there, or you can put it in code cells yourself and try out the different bits of code, and I really strongly advise to do that. Okay, can we get confirmation of attendance? Not sure how I would do that. So this is just an online stream, and so I don't really get to see who came along. Sorry about that. We've got an in-person session coming up on the 25th of September, and that's at Amazon Web Services venue in George Street in Brisbane, and so come along there. We can give you a confirmation of attendance there if you want. All right, let's go back to our code cell. Now I've put 4 lines of code here. The first 3 all start with a hash symbol, and that's because they're comments. So comments are things you put in code that don't actually do anything. And different programming languages have different ways of giving the marking something as a comment. All right. So send an email, please. All right. So if you looked, here's an email here. So it's skypieproject@gmail.com. Okay, so there you go. With that email will give you an invitation to the Slack channel, or if you need to ask any questions. But asking questions on Slack is probably the best, because then other people can see your questions as well. Okay, so where are we? We're in Google Colab up here. Okay, so we're going to run this code now. I've got 3 comments, and then I've got a question mark. Now the question marks doesn't actually work in all Python. It just works in what we call interactive Python. So what we get in Google Colab is pretty much all of Python plus a few extra interactive features. And interactivity with a programming language actually makes it a lot easier to learn. So I'm going to run this. And the question mark just basically brings up the help. You see it's underlined, so even Google Colab realizes that it's not pure Python, so they've put a squiggly red underline under it. And now over here on the right, you can get help, and it tells you how to get further help on different things. There's also a help menu up here. So very important on how to get help. I'm just going to close that now. All right, so let's start at the very basic building blocks of a programming language. And the first thing is, how do we store data? How do we use data? We want to store some data in some RAM somewhere in our computer, and then later on we want to get it back out. So that's where variables come in. Variables are names of memory locations where we store the data, and you can make up names pretty much anything you like. The only thing you can't use are what's called a Python keyword, and we'll come across them soon. So that'll give you a list of things you can't call your variables, but anything else you can. They have to start with letters. They can't, but you can include numbers in them. They can't include any special characters except for the underscore. So let's have a look at an example. A is a variable, and we're going to store the number 3 in it. And the way you do that is you just say A equals 3. So that's a line of code that we've written. You see we've got a comment above it to say what we're going to do. We're using the equals sign, which says put this value into this memory location. So if I run that, and I need to run it, otherwise it doesn't do it. It only does it when I run it. It's now run. It took 0 seconds to run, so very quick. And now A as a memory location storing the number 3. Now later on I can get that value back out and do something with it. So for example, I want to print it to the screen. So let's use the print function, which is a Python function. And so we call the print function, and we pass it an argument in parentheses what we want to give it, which is the value, a variable name, and it'll look up that memory location and display the results. So print A. Now that's a pretty common thing you'd want to do in an interactive Python. So in interactive Python, they can, if the last line of your code is just a variable or just an expression, it will display the results of that. So I can just put in A as the last line here and run that, and it'll say, yep, A's got the value 3. Now I could do an expression, so some sort of mathematical calculation. I'm going to add a value of 4 to the value that's stored in memory location A, and see if I hover over that, Google Colab's even telling me, remember that's a 3. So I'll have 3 plus 4, and I run that, and I get a 7. Alright. Now this is where, I really recommend you throw in a code cell yourself. So click on code and do something A times 5, and we'll run that, and it gives 15. So really good for getting a familiarity with how these expressions work. Alright, so here's an expression. So we got A plus 15 divided by 4, and we want the addition of 15 to A to happen before we do the division by 4. So we have to put parentheses around this at the addition, because otherwise it'll do division before addition using standard mathematical rules. And then it'll store the result into variable location B. And then we want to look at what's in variable location B, and so we just put B as the last line of the cell. So when we run that, we get the answer 4.5. Okay, now I'm going to give you some challenges as we go along, and so see if you can answer these. Now I'm going to do the solution also on the screen, so you can pause the video if you want to have a go at it yourself. But here we go. Here's our second challenge. Can't remember what the first one was, but our second challenge: add 123 to 456 and display the result. Okay, so I've left you a spare cell here that you can, a code cell that you can type the code in. So I'm going to type in my answer to this challenge, 123 plus 456, and it displays 579. Alright, so that solution, that's going to work in IPython. It's not going to work in normal Python. It'll calculate the number, but it won't know what you want to do with it. So here I provided a solution that actually works in IPython or Python, and it uses the print function. And inside the parentheses, I've just put the expression straight in there rather than having to do 2 lines of storing it in a variable and then putting the variable in there. I've just put the expression straight into the pass it into the function. And there we go, 579. Alright, now I've talked about Python keywords before. There's a way of finding out what all the Python keywords are. This is a little bit more advanced if you want to know why it's working, but so for the absolute beginners, you really just want to know what the keywords are. But for the people who are more have used Python before, you'll see that we're going to be using what are called standard libraries. So we're going to try to get some functions. This is standard libraries that come with Python, but you don't get access to them just normally. You have to import each library that you want and then refer to things in that library. So we're going to import 2 libraries. One's called keyword and one's called sys. And then to use something that's in that library, we'll prefix that thing. So we want to look at the keyword list. But we want to use the keyword list that's in the keyword library, so it'll now be keyword.keywordList. And the reason we want sys is we want to know what version of Python we're currently running. So let's run this, and it says the Python keywords are, and here's the list: false, none, true, and, as, assert, async, await, break, class, continue, def. Okay, there they all are, and there's only 35 of them, so that's not a lot, and that the whole Python language is based on those 35 keywords. Anything else, all the other functions, like even print is not a keyword. Print, you can actually change, you can use print if you want it as a variable name. I don't advise it, because then you wouldn't be able to use print as a function, because you've taken over that word. But they're the 35 keywords, so let's see how many we can get through tonight. And so I think first one we're going to look at is none. What's none? And so none is a value you give to a variable if you don't want it to have a value. So let's say n equals none, and let's have a look at what the value of n is, and it's nothing. We don't get anything out. So this is like in other languages, you've heard of null, say for Java, or nil, I think in I can't remember who uses nil, but most languages have a null value or a nothing value. That's basically we've got a memory location, we haven't got anything in it, so don't use it, and so that uses the keyword none in this case. So there's one of our keywords. Pass is another one. If you look along the list, you'll see pass, and pass is a keyword that does nothing in the language. So sometimes you need to use pass, and we'll show you later a case of why you'd need to. It's basically because Python relies on indentation of code, but if you've got a line that has that you want to have indented, but you've got nothing that you want to actually do at that line, then you put in pass, and so pass will show the code interpreter what the indentation is, but without actually then doing anything about it. Alright, so there's two keywords. Let's get back to variable names. It's better to use longer variable names rather than just A and B and N that I've used so far. But you and so a lot of variable names will have several words in them. Actually, I wrote here that also avoids clashing with the keywords, which is a good point. Now the convention in Python, you don't have to do it, but the convention in Python is to use underscores between the words, and when you're doing variables. So other languages like Java use camel case with no underscores, or title case. So in Python we're going to use, for variable names and function names, we're going to use they call it snake case, because it runs a snake along the bottom, and we will use title case when we're doing class names, but that's a more advanced topic. Okay, data types. The we've got some variables that we're with data in them, and each bit of data has got a type. So A, for example, is a type int, which is short for integer. So that's a whole number. It doesn't have any fractional part. It can be negative, it can be positive, it can be a very large number, it can be a very, very low negative number, but it never has a fraction. So they're integers, and they work very well in Python. You can have them as big as you want, and Python will just adapt. So there's not like languages like C or even Java, where you've got 64-bit limits on how big your integers can be. Python will just let them get bigger and bigger and bigger. So let's see. This is, we did a type of A, so it looked in the memory location A and gave us an integer. This is the type of 456, so we could put it literally, the number, straight into the function, and it's also an integer. Remember we did B before. If I hover over it, B is 4.5, and it's the type float. So float means floating point. In fact, if I hovered over that, which is now not going to do for me, it told me float as well up here. And the reason they call it float is because the decimal point can float around the variable up or down to give the magnitude of it. So you've got a mantissa and an exponent, and then the exponent tells you basically where the decimal point is, and the mantissa gives you an idea of what the number is. So here the exponent is 19, and so that's 10 to the 19 times 1.23456, and that's the same as this number here. So you could type it in either way, and they'll both give you the same number. Although it does truncate, it's limited to about 17 significant figures. So that's quite a large number. Here's another number which looks very similar, but with the decimal point way out here. So it displays the same way with the same mantissa, but it's got a different exponent. Now it's minus 14, so it's 10 to the minus 14 to say move the decimal point 14 times to the left. So there's some number data types, and now we'll have some text data types, which is basically a string. And this is the big difference between Python 3 and Python 2. In Python 2, every character in a string was limited to 1 byte. So you only had 256 different characters that you could display, and not even that many, because some of them were taken up with your control characters. And that was why they really had to go to Python 3 to be able to handle Unicode strings with all the different languages and different characters that are now in there. There are now thousands and thousands of characters in the Unicode alphabet. But anyway, we're stuck where we're now with Python 3, and it is way better than Python 2. And so now we've got our strings, and our strings we can define using quotes. Now you can use single quotes, as I've used here, or you can use double quotes, and they're really equivalent. There's no difference between either of them, except that if you want to embed double quotes in a string, you're better off to define the string using single quotes, because then it knows that it hasn't come to the end of the string when it gets to the double quote there. So if I started that string with a double quote and I came to a double quote within the string, it would think the string was finished, and then it would give me an error for this word double that was outside of the string. Similarly, if I wanted to embed single quotes inside the string, then it's better to use double quotes for my string. Sometimes you're going to have both single and double quotes. In fact, sometimes you even got line feeds in there. So these first two strings using single quotes and double quotes, I can't have line feeds in the string by pressing the enter key on my keyboard. So I use triple single quotes or triple double quotes, and then the string starts at the triple single quote and will continue on passing over single quotes, double quotes, until it gets to, even line feeds, until it gets to a triple single quote. And similarly, if I start with triple double quotes, then it allows me to have line feeds, singles and doubles. So I've created 4 strings here. I've put them in S1, S2, S3 and S4, and let's print them out and we'll see what the difference, how they look. So these look pretty much, they're just exactly what was in the single quotes or the double quotes. This one here, when I defined it, I lined the L here underneath the A, but when I display it, it puts in a lot of spaces, and the reason for that is that there are spaces there on the line. So this is a problem with trying to do line feeds in strings, is that they don't line up. The first line doesn't line up with the rest of the lines. So you'd have to do that. So S4, for example, if If I don't want spaces at the beginning of the second line, I have to align it right up to the left hand side. Okay. The last thing we did, what is the type of these strings, and it's str, so that's the abbreviation for string. Now I said you couldn't put line feeds or carriage returns in by pressing the enter key using just single quotes or double quotes, but you can do it using these as special characters. So special characters come in using a backslash. So backslash n for new line, backslash r for carriage return, backslash single quote if you want to put a single quote inside a string that's designated with single quotes, and similarly for double quotes. Of course, then the issue is, how do I do a backslash if backslash has all these special meanings? And of course, backslash backslash will give me a way of doing a single backslash. So let's have a look at what these look like. So one, I get a new line, takes me down to the new line. Then I print the and so what I'm trying to print here is I'm print the number 1, then my special character 1, then number 2, special character 2, number 3, special character 3. So my number 1 prints and then I print a new line. Then the number 2 prints, you can't see it, and the reason is because the next thing that gets printed is the carriage return, and carriage return means take the print head to the beginning of the line again. So it just wipes over the 2 and starts printing a space, and then the number 3. Then the 3 prints my single quote, my double quote, and my backslash. So that's how carriage returns work. I've never really had a need to do that, but there it is if you do. I normally use carriage returns. I would normally use that character there if I'm checking for Windows end of lines, because they're made up of a carriage return and a line feed or new line. Now for the advanced people who are really finding this very easy, we've got some more things that you can do with strings, and they're different sorts of strings are defined by putting a letter out the front. So there's 4 different letters you can put out the front of a string. You've got U, which gives you a Unicode string. So that's all strings by default in Python 3 have a U, but if you were doing this in Python 2 you'd have to put a U there. And the reason they made U's work in Python 3 as well is because some people wanted to write code that would work in either Python 2 or Python 3. So they allowed the U in front for Python 3. Similarly, if you want to write a string using a Python 2 type byte string, then you put a B out the front, and then you put your characters here, and they're just limited to the 255 ASCII characters, and the ones in different character sets, but it's just 1 byte per character, and that's called a byte string. Now this one here is the raw string, and a raw string basically says to display backslashes as they are and don't give them the special characteristics. So let's run this and see what it comes out like. So a raw string where the backslash is still a backslash. So then if I do a backslash by itself, or backslash n, backslash r, backslash t, they all just show like that. Alright. Now the one thing you can't do with that though is have a backslash as the last character. And I'm not sure why. There's some good reason for it, but even in a raw string the backslash still has a special characteristics, which means don't have it at the last character, otherwise it won't see the final double quote. And this one's my favorite, the format string. So we put an F out the front, and a format string says that if anywhere in the string it finds these curly braces, it will evaluate the expression of the curly brace inside the curly braces and display it, rather than what the it'll display the evaluation of the expression, not what is the expression itself. So in this case, A has been substituted with 3, B has been substituted with 4.5, and A plus B has been calculated to be 7.5, and that displays as 7.5. And there's a whole lot of formatting you can do with f-strings that make them very, very powerful. They've only been around since Python 3.6, but quickly the whole Python community is using them in favor of any other way of formatting strings. And in fact, I'm going to get straight into using f-strings for displaying results. So here we're going to look at operators. So operators are things like your plus and your minus. So the asterisk, which is used for times, double, slash, which is used for integer division or floor division, percent, and which is used for modulo, and asterisk, which is used for power. So you can see I've created some f strings here that are going to show what I'm calculating and then calculate it and tell me what it is. So let's have a look at what the results are. So I've got 27 and the plus sign and 5, and that gives you 32. So that's addition. So that's how you do addition in expressions. We've got subtraction, multiplication, not quite so obvious, it's just as an asterisk or a star. Integer division, so that's 27 divided by 5 is 5 remainder 2. So that gives you the 5, and the percent gives you the 2 remainder, so 5 remainder 2. And then 27 to the 5th power gives you this number here. Now you'll notice that all these results are integers because they don't have a decimal point in them. But what happens when one of those numbers is a floating point number? So let's change the A. Rather than being 27, it'll be 27.0. So in effect it's the same number, but Python will store this as a floating point number rather than an integer. So let's run the same operations. So if I have 27 plus 5, it still returns 32, but it's 27 float plus 5 int returns 32 float. And I can tell it's a float because it's got the decimal point and 0 at the end. And I could also use the type function if I wanted to confirm that that's a float. Similarly, minus is a float, times is a float. Double slash is a float, that's a whole number division. But we've now got another operator, which is the single slash, and that works in floating point numbers to give me a floating point result. So 5.4. So 27 divided by 5 is 5.4. Modulo still works, power still works, but still giving floating point results. Okay, so we've got a challenge here. Store in the variable C the number 123,456,789 and display double the value of C. Okay, so we click in our code cell and have a go at this yourself. C equals 123,456,789. So like you might be tempted to put commas in there, but that won't work because commas are used for other things in Python, so you can't do that. So we'll do it all just one long number like that, and we'll display double the value, so 2 times C. And there it is, 246,913,578. So let's look at the solution. This is a nice little feature in Python. When you look at working with big numbers, big integers like this, you can use underscores instead of commas. And so that's why you can group it into your thousands and your millions. And then we can print it out. So we'll say C, double C equals D. we can also use f strings. We can put the evaluation straight into the f string. 2 times c equals 2 times c. Let's run it so we can see the results. So we got 2 times c equals that. So you can see I actually wanted to print curly braces in my f string, and the way I did that was by putting double curly braces. And then it realized that they weren't the ones that it needed to calculate the expression, value of the expression. So it just printed it out literally, and we got the result. And now in other expressions, if you want to put a format, you put a colon in there, and then anything after the colon is the format that you want to use. So I want to use underscores just like I typed it in, and it prints out the number using underscores. Alright, we can format it using comma, and so we can display it out, put a comma, even though Python uses commas for other things. When you're displaying results, you can use, it'll display commas because of course it's quite a common thing to do. And you can even say I want it to display it 17 characters wide, I want commas included. We've got a full stop. So the decimal point, I want to have 3 decimal points, and I'm going to tell it that's a floating point number that I'm starting with. And there you go. There's the result. Okay, so we've got a couple of comments here. I go to another university. I'd like to see MATLAB. And Python is just importing simulator. Teach them C. Okay. So if you want to look at our past sessions, we've got a GitHub repository, and all the ones we've done online are in the online folder. And if you look through here, you'll see I might have done some oh, you're saying MATLAB. I was thinking matplotlib is what I was thinking you'd said. So if you're after matplotlib, and we don't actually have any in the I've definitely done them, but that was before we were doing them online. So we've done ones with Plotly, quite a few, so you can have a look at those ones, and they're a combination of Jupyter notebooks and Python scripts. So if you look in one of them, you'll see it'll have often have a link to a Jupyter notebook and a YouTube video that you can work through. Okay, challenge 4. Find the remainder after integer dividing an odd number by 2. Then try an even number. Okay, so I can actually do these on the same line. So let's try an odd number. 5 modulo 2 will tell me what the remainder is after dividing an odd number by 2. I can also do, let's try 8 modulo 2, and that's an even number, and that gives me 0. Now you notice it's only given me the last value because that's how notebooks work in IPython, but I can actually calculate 2 expressions on the one line, just put a comma between them, and it'll tell me the 2 results. So it's 1 for the first one and 0 for the second one. Okay, so I've got a solution here, and this is going to loop through a bunch of numbers, and it's going to use a for loop. So I want I to go in a, and we'll just run it and see what it does. And it prints I modulo 2 equals I modulo 2. So I, the first time through the loop, I is equal to 0, and then 1, and then 2, and then 3, and then 4. And if we look at the remainders, after dividing by 2, we can see the remainder is 0, 1, 0, 1, 0, 1, which is quite an interesting pattern and something that that would be useful for other things. Now the way this loop works is that we've indented the code that we want to be in the loop, and that's called a code block. Now there can be more than one line there, but we've only got one line indented. And basically in Python, when you're about to start a code block, on the previous line you end the line with a colon, and it says like I'm starting a new code block, and in the code block are all the lines that I want to be part of this line here. So this line here is my for loop. It's going to run that 5 times because it's in range 5, and the value is going to go from 0 to 4, and this is the code that's going to be run every time. And that's indentation. So I was mentioning before, you'd use pass if you wanted to run your loop 5 times but you didn't have anything to do in the loop, so you might have had some other reason why you're running in a loop, so you could put a pass in there. Maybe sometimes, a typical case would be you're going to put something in the loop, you haven't worked out what it is yet, so for now I'll put a placeholder in there, I'll just put the word pass. A comment won't do, you can't just put a comment there. So if I was going to do that, I'd put a comment to say put in the proper code and then put the pass, and then later I search for my to-dos and go, oh yeah, I've got to put some code in here. Okay, let's go on to a more advanced topic here. We're going to look at bitwise operators, and they work on binary numbers. So we're going to start with just some decimal numbers, so a equals 10 and b equals 3, and then we're going to see what happens when we use these operators. So we've got a pipe symbol, just a vertical line. We've got the ampersand symbol, and we've got circumflex, we've got double less than and double greater than. Okay, so let's run these and see what results we get, and see if you can work out what they're doing. So 10 pipe 3 returns 11. 10 ampersand 3 returns 2. 10 circumflex 3 returns 9. Okay, so these numbers look a bit random. Where are they coming from? So another thing I can do in my f strings is I can convert them to binary. So remember before we had a floating point number was f. Well, here's a b for binary, and I can say I want it to be a 4-digit binary and 0 padded, and I can print the results there. So in binary, 10 is 1010, 3 is 0011, and if I go 1010 or 0011, I get 1011, and that's called bitwise OR. So the way OR works is it's if either of them are a 1, then the answer is a 1. And so we get the only value is a 0 is where both the second digit here and the second digit here is a 0. We get the second digit here as a 0. Similarly, if we use the ampersand, that's bitwise and it's only a 1 if both of them are 1s. And in this case, the third digit is the only situation where both of them are 1s. So we get 0010. When you convert that back to decimal, you get the number 2. So these are bitwise. They used quite a lot in electronics. They're used in encoding things. So I'll just quickly go over what the rest of these are. Exclusive OR, that's if either of them is a 1, then it's a 1, except if both of them are 1, then it's a 0. So 2 zeros give you 0, 2 1s give you a 0, 1 and a 0, or 0 and a 1 give you a 1. Okay, these are the shift operators. So 3 left shift 2 returns 12. So what that basically means is if I start with number 0011 and I shift those 1s 2 places to the left, I'll get 1100. And when I convert that back to decimal, I get 12 in this case. So that's effectively the same as multiplying by 4. So every time you shift left by 1, you're basically multiplying the number by 2. And similarly, if you shift right by 1, you're dividing by 2. So 13, shift right 2 times, that'll give you 3 as an answer, because you basically divide by 4, and any remainders just get ignored. So that was our advanced topic for tonight, was bitwise operators. Now we'll go back on to our normal, more mainstream operators like the plus and the star, and they also work with strings. So we've got a string here, well. We can actually multiply that by 3, and we get well. Then we can add the result of that to another string, and we get 3 holes in the ground, and that gives us a total string. An odd thing that Python can do, I don't really see the value in this, and I think it causes potential for bugs, but when you're adding strings together, you don't even need to put a plus sign between them. You can just leave a space and it'll add them. So if I have these 3 strings next to each other with no plus or any operator between them, it'll just concatenate them all into one long string. Okay, interesting side effects. Now I mentioned before that integers can be as big as you like, and it means that integers can actually have more significant digits than floating point numbers, which is different to other languages. Other languages you're used to floating point numbers being able to handle a larger range of numbers than integers. But in Python, the integers can go bigger without losing any precision. So floats, they're limited to about 17 decimal places, or floating significant figures, 17 significant figures, but integers just have as many as you like. And this wasn't always the case. Python 1 didn't have this, but I decided to add that in later. So for example, if I had 25 divided by 7 using floating point, I just get that number of significant figures. But if I put a whole bunch of zeros in there and just pretend there's a decimal point in here, then my integers that I get here is 3.57, and it just keeps going on and on and on. And if I put in more zeros, this number would just have more and more places. So that's really useful. I've seen some novel ways of taking advantage of this. For example, if you wanted to calculate pi to 1,000 decimal places, how do you store a number that's that big? And you just multiply it by 10 to the 1,000 and store it in integers, and Python will handle all those decimal places for you. Now, because floating point numbers do truncate numbers, any number that can't be stored as a binary number exactly will have what they call a floating point error in it. So they're great for science because they're very fast to do the calculations. Complicated calculations can be done very quickly using floats, but they're not great for accounting because you'll find little instances where they just don't add up. So here's an example where they don't add up. Say I wanted to say 1 plus 1 plus 2.2, and what's the result of that? And it's 3.3, and then lots of zeros, and then a 3. And it's because each one of these numbers has got a bit of a floating point error in it, and by the time you add them together, that floating point error is just too large, and it will display a result like this. Now you can always truncate it when you're just outputting the results, but eventually they could add up and you'll get fractions of a cent. That eventually you'll get a cent difference, and for accountants don't like that sort of thing, so don't use floating point numbers for accounting. Use integers, so you could just store everything in cents and just have them as integers. Or if you really want to use dollars and cents, then there's a class called decimal, and that will give you exact calculation results. Okay, challenge 5. Find the integer quotient remainder after dividing 66666 by 235. So we can go 666666. We'll find the quotient and we'll find the remainder. (2,836) remainder 206. So calculate 2 to the power 10. So do you remember all our operators? We've got an operator double star, and that's saying take it to the power. Find the decimal quotient of 66666 divided by 235. So in this case, we don't use the double slash, we just use a single slash, and it will give us a floating point answer. And especially if I type in correctly, there's our floating point answer. Okay, store in a variable the name of your favorite Python programming language. So let's say P equals Python. And construct a new string that starts with programming in plus P plus is fun. There we go, programming in Python is fun. And so you notice I left a space here and a space there, so that this string here had spaces around the name of the programming language, and that's just showing the plus operator for concatenating strings. So let's go down to the solutions for all of these. All pretty much the same, except for the string one. An alternative way of constructing strings is using f strings, and that's what was done here. Okay, another data type is the Boolean, and this stores trues and falses, and we use Booleans quite a lot. There are, like, if you're ever comparing two numbers, is this number greater than that number? That the answer to that's going to be either true or false. We look at what the type of these are actually keywords, true and false, and you can see that they're coloured in a dark blue colour, and each of those is of type Boolean. Now if we want to compare two numbers, say we want to compare 3 to 5 minus 2, we see if they're equal and we use double equals, and the reason is because we've already used single equals for assignment. So if we want to compare two numbers, we use a double equals sign, and that's pretty standard in a lot of programming languages. So does 3 equal 5 minus 2? And the answer is true. 45 greater than 23? That's true. Minus 10 less than minus 20? And that's false. So you can see these results from these are operators. They take in two values and return a single value, and that value has in these cases, true and false. C1 equals Python. True. Alright, so I've got a challenge here, so you can read through it, decide what you think the answer is going to be, and then run it and see if you got it right. So let's see if C1 equals Python. So remember what C1 is? It's Python here. Here we checked it, that was true. So if we run this, what are we going to get? So I'll leave these ones for you to work out, and you just run it and you see, and it returns false. And that's because C1 is Python with a capital P. So you can see that when it's checking if two strings are the same, then it checks whether it's a case sensitive check. So we've got a question here: can Booleans results be used in mathematical equations, as in true equals 1, false equals 0. And that is, you can actually do that. So if I did true plus true plus true, it comes up as 3. And if I multiplied all that by false, we get 0. And the reason that is because these Boolean numbers are an extension of the integer class, and so they do have the values of 1 and 0 for true and false. Let's see. C1 does not equal Python. Well, we just saw that C1 equals Python was false, so C1 does not equals Python is true. 235 greater than or equal to 1518 divided by 6. And that's true. So I'd like to know what 1518 divided by 6 is. And that's 253. So we're comparing 253 to 253 with greater than or equal, and that returns true because it is equal. And you notice how we compared a integer with a floating point number, and so you can use equals on those and it'll still return true. Similarly, 253 is less than or equal to 1518 divided by 6 is also true. Math.e is less than math.pi. So pi is 3.14, etc. Math.e is your exponent, so 2.718, and so that returns true. So there's a few, I'm just showing you this. The standard library math has a few of these useful mathematical constants in it, and that's how you can access them rather than having to type in the number. And that's probably a bit more readable. If people look at your code and you see that you're using math.pi, they'll know that you're doing some sort of circular calculation rather than just seeing this number and going, where did that come from? Alright, we've got math.e, math.pi times 2, math.tau. Now, when I first wrote this, I didn't know what math.tau was, but apparently it's 2 times math.pi, exactly that. So if I said, is math.pi less than math.pi times 2 less than math.tau, the answer is false. This also demonstrates that you can use the operators more than once in a series. So that's saying, is that bit true, and is that bit true? All right. Sorry, just losing my voice here. So we can compare text as well. So comparing A to C. I was going to drink of water. All right, comparing A to C, and we get true because A is earlier in the alphabet than C when you use less than. And the way that works is it actually calculates the Unicode values of each of these characters and compares the Unicode numbers to each other, which has a few interesting side effects. So if I compare A to capital C, I get that capital C is actually less than lowercase a, and that's because in Unicode and ASCII all the uppercase characters appear before the lowercase. Well, actually that's for the ASCII part of the Unicode table. Now if I compare upper to lower, this is a bunch of uppercase characters to a bunch of lowercase characters. That returns true, so all the uppercase characters appear first. If I'm comparing strings that start with the same characters, it does it just like we would look at in a dictionary. Is it goes, well, if the first ones are matched, the second ones are matched, the third one it compares T to R and goes, no, T is after R, therefore that's false. I can also, there's an operator here called in, and we can say is the string AT in the string catch. And AT in catch returns true, AC in catch, even though both A and C are in catch, but that returns false because it's not as a substring. And similarly for TA, that returns false. And you can see I've done some pretty fancy stuff here with single quotes and double quotes inside, or single quotes inside a double quoted string. Okay, true or false returns true. Yeah, so what we're looking at here is the operator OR and the operator AND. And we've also got, if you use both of them, this is one that confuses me, what the result is going to be for true or false and false. And the reason is the AND has precedence over the OR when it does order of operations, so it's going to calculate false and false first and then go, well, that's false, so therefore false or true is going to result in true, and that's correct, that's what it returns. And there's just another example of that. Okay, and you'll see there's another keyword is, very similar to equals, but I wouldn't advise beginners to use it, because it means for two variables to be the same, they have to refer to the same location in memory. So they're going to have the same value because they're referring to the same value place in memory, but the is basically saying is that what they are. So that's an example of using is to return true. Now last month we looked at lists and other collections in detail, but I'll quickly go over it here. So we can define a list as another data type and just use square brackets around it, and you can have strings and floats and even other lists in there. And then you can refer to different parts of the list just by indexing it. So the 0th element is 6, SIX, the 1th element is going to be, so it's their 0 index, so 0, 1, 2, 3, 4, 5, 6. And you can see that that's how we get them. It's got some nice things you can do in Python, like you can count the index back from the end and use negative numbers. I haven't seen this in other languages. So list minus 1 will give me the last element in a list. Similarly, list minus 2 will give me the second last element. And I can find how long the list is using the built-in function len. I can get a slice of the list. I can go from 2 to 5. So these are the indexes, and it gives me 4, 3, 2. So that'll give me starting at 2, going up 2, but not including 5. And the way I like to think about this is, if I've got my list here with my contents in it, the indexes are not actually in the middle of the values, they're at either end. So it goes 0, 1, 2, 3, 4, 5, 6, 7. So if I want to see what I get from 2 to 5, the data I get are these 3 elements here. And that's why it goes up to, but doesn't include the 5th one. And it also has the other advantages. If I want to know how many I'm going to get back, 5 minus 2 is going to give me 3. So I'm going to get 3 results back from doing a slice. And I've also shown here you can use the negative numbers for the parts of the slice as well. You can leave, when you're doing slicing, you can leave a value out, and then it'll assume the beginning if it's the first number, or the end if it's the last. Let's just run these to see. You can even put in 2 colons. So this is saying start from 1, go up to, there's no value there, go up to the end, but then after the second colon it tells me how I want to step. So I'm going to go every second one, so I get 5, 3, 1. And you can even step backwards, so there's a neat way of stepping backwards. So that's the last element, second last, third last, fourth last, etc. Going up to, but not including number 1. So number 1 is the value 5, so it doesn't include that value. So another look at the list. I'm going pretty quickly through this because we did this a few weeks ago. I can assign the second value to FOUR, and now when I display my list, you can see 4 has been replaced with FOUR. I can change the last element from 0 to blast off. I can delete items in the list, so I've deleted 3, which will be this one here, and that's 3 from index, not 3 from the number, the string value 3. It's just coincidence, they're the same. Okay, so they're lists and how you index items in a list. So list is considered a sequence, but another variable that you might not think of as a sequence is a string. It's a sequence of characters, and so a lot of these things you can do the same. So you could slice from 3 to 7 to get the 4 letters in the string, D, E, F, G. A string is not mutable like a list, so we can't change characters within the string without assembling a brand new string. I talked about decimals before. If you want to do accounting, remember we had that issue 1.1 plus 2.2. So we can import, it's a standard library, so I don't need to install anything else. And then if I say what's decimal.decimal 1.1 plus decimal.decimal 2.2, and the answer is decimal 3.3. Now that's a fair bit of typing to do that. I'll just leave a question with you as well. Why are these in strings? Why don't we just type in 1.1 and 2.2? And I'll see if someone can come up with the answer to that. But while you're thinking about that, how can we reduce the amount of typing that we do? And one of the ways is, rather than saying import decimal, we can say from decimal, we only want to import the class decimal. And if we import it that way, it means we don't have to qualify every time we use it with decimal dot at the beginning. So in this case, it's capital D decimal 1.1 plus decimal 2.2, and that even looks good for the way that it displays, which is decimal 3.3. We can actually save even more typing by using an alias. So I want to use the standard library decimal. I want to import the class decimal with a capital D, but I want to refer to it as just D every time I want to use it. And so this means I can use it as D 1.1 plus D 2.2, and that saves me a lot more typing in the code. Of course, when I display it in IPython, it displays the full class name, but I didn't have to type that, so that's not an issue. You can use aliases. You probably see this if you're using the pandas library or the numpy library. Most people will import pandas as PD and numpy as an NP, and that just saves a bit of typing every time they use pandas or numpy. So there you go. I've covered, these are the keywords that I've covered. There were 35 in total. So I've just put them all in a string there, separated by pipe symbols. And then I said split the string on the pipe symbol to give me a list. And tell me how long the list is, and it's 14. So of the 35 keywords, tonight we've covered 14 of them. So you've done a significant proportion of the Python language. We've just done in 1 hour. So I hope you found that useful. Thank you for all the questions that came through. And next week will be a machine learning session presented online by Arun. The following week I'll be doing a Django session, which will be a continuation of part 1 in Django that I did recently. And then on the 25th we will have an in-person session. I'd love to see you all come along. We're looking for presenters. If anyone's feeling up to presenting, let us know. You don't have to be a total expert in this. It's generally good if you are reasonably new into a topic, then you can present to other people who are reasonably new into the topic, because you understand the problems that they're seeing. Okay, thank you.